Hi guys, we're talking today note-wise on molarity, molality, and solutions Stoich. So molarity is a unit. It's kind of like units of grams. We have moles, we have liters. Molarity is just a unit that we use to measure the concentration of a solution. So sometimes like in the lab, I'll say, you have like a 3.0 molar solution of hydrochloric acid, or I'll have a 1.0 molar solution of hydrochloric acid. The 1.0 molar is more dilute than the 3.0 molar solution. So it's just talking about concentration. This is most useful for stoichiometry. And here we see the equation is molarity is the moles of solute divided by the total liters of solution. So we need a value for moles of the substance that we're dissolving. And then what's the total amount of liters, the volume of the solution that we made? And this ratio is going to compare the solute to the entire solution. Molarity is defined as the number of moles per solute per liter solution. Notice that the volume is of the whole solution, not just of the solvent alone. So here we see this is how I would do it in the lab, how I would make it. I would take copper sulfate, like the crystals that we have. I take the mass of it to get a certain amount of moles. I put it into our volumetric flask, and then I'd add water. As I add this distilled water, though, I'm stirring it, and then there's this like line, and that line is for like my accuracy. And when I get to that line, that is when it stopped. It's not just the volume of the water, it's the volume of the water and of the substance as I mix them up. And then in this scenario, we made a 1 molar solution of copper 2 sulfate. So here it says you need 1 liter of a 0.15 molar solution of NaCl. How are you going to prepare it? So thinking about this, we need to know a few things. So it just says 0.15 molar. So that's the molarity. That's the concentration. This is our volume. So we need to figure out moles. And in the lab, I can't figure out moles unless I know grams. So I can't have a device to use to measure for moles, but I can measure for grams. So I need to figure out how many grams. So this is just something that we think about. We think, okay, I have the concentration, I have the amount, and I need our volume. So all of that stuff comes into play when we're trying to figure this stuff out in the lab. All right, so making a solution. Here's a practice question. What mass, some of you have seen this on our mastering, what mass of sodium hydroxide, which is NaOH, is required to make 500 mLs of a 0.25 molar solution? So it gave us volume, it gave us molarity. Using the molarity equation, we need to first solve for moles. After we solve for moles, then we can convert to grams. So our molarity is moles per liter. That's what we see here. So we plug those numbers in, and we need to solve for X. To solve for moles, we have to then get rid of the volume in our denominator by multiplying it out. So both sides need to be multiplied by 0.5. The reason we're using 0.5 instead of 500 is because it's moles per liter, and this is milliliters, so we had to have that first in liters. So we're multiplying molarity times our volume to find moles. So in this scenario, we have 0.125 moles of sodium hydroxide that are required. And we can't, again, measure anything, use anything in the lab to find moles, so we need to figure out how many grams. So just like at the beginning of the year, we put what we're given of moles over 1. So 0.125 moles of sodium hydroxide over 1. We have to get rid of moles of sodium hydroxide, so that goes to the bottom of my next line. And using the molar mass, I can convert to grams by putting grams at the top of sodium hydroxide. And I find the periodic table of sodium is 23.0, oxygen is 16.0, hydrogen is 1.0. Add them up, I get 40.0. So then I multiply the top divided by the bottom, and I get 5 grams of sodium hydroxide. So that's just an example that you've seen here. There's also several problems in your mastering. And then in your quiz I think it only asks you to go to moles. So just a little information there. Another term that's really similar is called molality. Molality is also another unit that we use to measure concentration. However, we don't usually use this with Stoich. We use it with colligative properties. Molality is very similar to the equation for molarity, except molality is the moles of solute per kilogram of solvent. We only, again, use this to determine colligative properties using how much did the freezing point go down, how much did the boiling point go up. So we have, again, moles of our solute, so the substance that we're dissolving, divided by the kilograms of our solvent. We use the unit is a little cursive m. So molarity is big capital M, molality is little cursive m. And this ratio compares the solute to the solvent. Here's an example problem. How would you prepare a 0.50 molal solution of glucose in 500 grams of water? So it gives us the concentration in molality. It gives us grams, and remember that equation, we need kilograms, so we have to divide this by 1,000. That's going to be in our denominator. X is the number of moles. We don't know how many moles, but we do have the concentration. So what we're going to do here is, again, solve for X by multiplying 0.5 by 0.5 to get 0.25 moles of glucose. However, again, in the lab, I don't have a tool to measure moles. So what we need to do is we need to convert moles into grams to figure out how much I need to use and weigh it out. So we're going to put the moles over 1. So 0.25 moles of C6H12O6 over 1. Get rid of moles because that's what we're trying to get rid of. We're converting out, and we want grams, so grams goes on top. Molar mass when we're using grams to moles. So 6 carbons, 12 hydrogens, 6 oxygens add up to 180.0. Multiply the top, divide by the bottom. We get 45 grams of C6H12O6. All right, solution Stoich. I know you guys love stoichiometry. It's so much fun. I love it. It's when we use our, mole-to-mole ratio with our balanced chemical equation so we can go from one substance to another. So remember molarity, we need moles of the solute per liter of solution. So what mass of calcium sulfate, so looking at our formula here, calcium sulfate is this product over here, will be produced from the reaction of 10 liters of 0.025 molar calcium chloride solution. So this information here is for calcium chloride, and that is our first reactant over here. So we have enough information to solve for moles of calcium chloride, all right? So what we're going to do is we are going to solve for moles, and then once we have moles of calcium chloride, we're going to then convert it out, go mole to mole, find how many grams after we go mole to gram, how many grams of calcium sulfate were produced. So here we see a bunch of Stoich. So 10 liters over 1, get rid of liters, go to moles. Remember, molarity is moles per liter, so this many moles in 1 liter. So that's why we were able to use that as a conversion factor. So get rid of liters, go into moles using, again, this is our molarity. I don't want moles of calcium chloride, though. Initially, I do. But at the end, I'm looking for calcium sulfate. So I have to get rid of moles of calcium chloride. And after I get rid of moles of calcium chloride, I'm going to use my mole-to-mole ratio to go to moles of calcium sulfate. And looking here, this balance equation, they don't have coefficients, which means their coefficient is 1. So 1-to-1 ratio. Get rid of moles of calcium sulfate, go to molar mass, because we're looking for grams, multiply the top divided by the bottom, and we get our value here of 34 grams of calcium sulfate. All right, here's another example. It's all worked out for us. So what mass of silver chloride can we produce from 450 mLs of 0.15 molar silver nitrate with excess calcium chloride? So we were given information about silver nitrate, but the question's asking us about silver chloride, all right? So we need to use our stoichiometry to convert. Start with our volume. Remember, our volume needs to be in liters, so we divide this number by 1,000 and get 0.450 liters. Put that over 1, and this is of AgNO3. Get rid of liters and go to moles by using the molarity. Molarity was 0.15 moles per liter, so that's why 0.15 moles per liter. but I don't want moles of silver nitrate, so that's going to go on the bottom of my next line. But I'm converting moles of silver nitrate into moles of silver chloride. We use our coefficients, our mole to mole. We see our coefficients 2 to 2, 2 to 2. Get rid of moles of AgCl and go to grams of AgCl because the question's asking what mass. Mass is measured in grams. We get this value from adding Ag plus Cl from the periodic table. Multiply the top, divide by the bottom, we get an answer of 9.7 grams of AgCl, or silver chloride. And here's our last example. So the question is saying, what concentration of salt water is produced from the reaction of 250 milliliters of 0.5 molar sodium sulfate and 350 milliliters of 0.4 molar barium chloride. So this is a limiting reactant equation. This one's a little bit more complex because you have to do two Stoichs and find out whichever one gives you the smallest answer. That's the one you're going to go with, right? So set it up just like you did before. We start with our liters. So for sodium sulfate, we're going to start with 0.250. Get rid of liters, go into moles by using the molarity. Get rid of moles of sodium sulfate and convert to moles of sodium chloride using their coefficients of 1 and 2. We get 0.250 moles of NaCl. Then for our next one, we're going to use milliliters, convert it to liters. It's going to be our first thing. This is barium chloride, so BaCl2. Put it over 1, get rid of liters, go into moles by using its molarity of 0.4 moles per liter. I don't want moles of barium chloride, so it's going to go on the bottom of my next line. And I'm going to convert mole to mole, converting moles of barium chloride into moles of sodium chloride. Again, look, they're both going to sodium chloride, so we can compare using their coefficients of 1 to 2. All right? Multiply the top, divide by the bottom, we get 0.280 moles of NaCl. Looking at these two, remember these are a limiting reactant problem. We have to go with the smallest amount that we can make. Remember the cars, bodies with the tires, and we only had enough tires to make, like, let's say 4 cars, whereas we had like 10 bodies, and you can only make as many as the smallest amount will make you. So that's why we're only going to be able to make 0.250 moles of NaCl. So that being stated, we're going to use that as our moles, and we're looking again for concentration. So since we're looking for concentration and we're putting two liquids together, we're looking for the total volume of the solution. So we have 250 mLs and 350 mLs. We need to add them up to get our total value for volume. Again, we need volume in liters, so that's why down here you see that they're converted. And I'm going to divide those, so our moles by our liters, and get an answer of 0.417 molar NaCl. I hope this information is a little bit helpful for you. I know I went through it fast, but there's also a lot of YouTube videos of me working out the problems in our packet that I handed out before we left for break. And those are really, really useful. So please feel free to email me a specific question. Maybe I can work it out on like a piece of paper for you and like go through it with you so that you're more solidified on your answer. And I hope you guys have a great day. Thanks. Bye.